channel. Today we will talk about sidebands, double sidebands and single sidebands. Introduction to sidebands. Sidebands are the frequency compounds that surrounded the carrier signals. Double sideband modulation involves transmitting the carrier and both sidebands. Single sidebands modulation transmits only one sideband and carrier reducing bandwidth. Sidebands. Sidebands are created in the modulation process of combining the carrier signals with the modulation signal. Upper sidebands and the frequency above the carrier will lower sidebands are frequency below the carrier. Sidebands carrier are actually information in a modulation signal. Double sideband. Double sideband modulation is a type of amplitude modulation in the transmit both the upper and lower sidebands. Double sidebands Double sidebands requires more bandwidth compared to single sidebands due to the transmitting both sidebands. Double sidebands is similar to generate and demodulate the single sidebands. Double sideband advantages. Double sidebands provide a simple implementation compared to other modulation techniques. DSB is less complex in terms of modulation and demodulation circuits. DSB is commonly used in an application where bandwidth is not a concern. DSB disadvantages. DSB requires more bandwidth due to the transmit both sidebands. DSB is less efficient in terms of power consumption and compared to SSB. It is more susceptible to interference and noise due to its wider bandwidth. Single sideband. Single sideband modulation transmits only one side along with the carrier, eliminating the need of transmitting both the sides. SSB is more bandwidth efficient compared to DSB as it requires less spectrum for transmission. It's widely used for long distance communication and radio broadcast. Advantages of single sidebands. SSB is more bandwidth efficient, allowing it more channels with given frequency spectrum. SSB provides better power efficiency compared to DSB, making it suitable for long distance communication. SSB offers improved signal to noise ratio and better quality transmission. Its disadvantages. SSB modulation and demodulation are more complex compared to double sidebands. SSB requires more equipment to generate and reception. It can suffer from the carrier suppression issues if not properly adjusted. Application of sidebands. DSB is commonly used in a AM radio broadcast. SSB is widely used in a long distance communication such as radio and military applications. Sidebands plays a crucial role in transmitting information efficiently over the airways. Conclusion. Understanding sidebands and SSB modulation techniques is essential for efficient communication. Each modulation scheme has its advantages and disadvantages, creating the specific application requirement. The choice between DSS and SSB depends on factors like bandwidth, efficiency, power consumption, and easy to implement.